In 2023, a small team of data scientists at Stanford fed 17 years of nonprofit tax filings into a machine learning model and asked it a simple question: where does the money actually go? Within 4 hours, the AI had mapped 847 previously unknown financial connections between shell organizations across 12 countries. The U.S. Treasury's own investigators had spent 3 years manually tracing the same networks and found fewer than 200. The AI found 4 times as many in the time it takes to watch a movie. That gap, between what human investigators can see and what artificial intelligence can see, is the story of a hidden war that is reshaping how power and money actually move in the world. Dark money is a specific legal term. It refers to funds that flow through politically active nonprofits, organizations classified under Section 501(c)(4) of the U.S. Tax Code, that are not required to disclose their donors. This is not a loophole in the traditional sense. It is a feature written into the law. After the Supreme Court's Citizens United decision in 2010, the floodgates opened. In the 2020 U.S. election cycle alone, dark money groups spent an estimated $1 billion influencing federal races. By the 2024 cycle, that number had climbed to over $2.4 billion. Nobody officially knows where most of it came from. That is the point. What makes this matter to you right now, in 2026, is not just the scale of the spending. It is who is doing the spending and what they are buying. When an anonymous donor channels $80 million through a network of interlocking nonprofits to fund a coordinated campaign targeting a specific regulatory ruling, say, pharmaceutical pricing policy or environmental standards, they are purchasing policy outcomes without ever appearing in a public record. Your medication costs, your energy bills, the zoning laws in your neighborhood. All of these can be downstream consequences of money that officially does not exist. Simultaneously, foreign actors have increasingly recognized dark money infrastructure as a soft power tool. The Senate Intelligence Committee documented in 2022 that at least 3 foreign-linked entities had successfully used domestic nonprofit shells to fund influence operations. The AI arms race to expose these networks is therefore not an academic exercise. It is a live battle over whether democratic systems remain legible to the people who live inside them. To understand why AI changed this fight, you need to understand why it was previously unwinnable. For decades, campaign finance investigators operated like archaeologists with a single brush, working one artifact at a time. A nonprofit files a Form 990 with the IRS once a year. That document lists the organization's revenue, expenses, and grants to other organizations, but not donor names. A sophisticated dark money network might involve 30 or 40 of these organizations, each passing money to the next, each filing separately, each legally compliant at the individual level. Human analysts trying to trace these chains faced a combinatorial explosion. Connecting 30 organizations across 10 years of annual filings means potentially reviewing 300 documents and cross-referencing millions of data points to find patterns. That is not detective work. That is data processing. And for 50 years, humans were the only available processors. The first revelation from the new generation of AI tracking tools is how much signal was always hiding in plain sight. Organizations like Open Secrets and the investigative outlet Documented have begun deploying natural language processing models that read Form 990 filings not as isolated documents, but as nodes in a living network graph. The AI does not just look for money flowing between named organizations. It looks for clusters of behavioral signatures, shared addresses, overlapping board members, synchronized filing dates, grant-to-revenue ratios that fall outside statistical norms. In 2025, a model built in partnership with the University of Michigan's Computational Journalism Lab flagged a cluster of 14 nonprofits that shared a single registered agent in Delaware, had collectively received $340 million over 8 years, and had each disbursed nearly 90% of their income to a common set of downstream recipients, none of which were public-facing organizations. Think of it like this. If 17 strangers all use the same post office box, all receive letters from the same 6 senders, and all immediately forward those letters to the same 3 addresses, the pattern is obvious from above even if each individual letter looks perfectly normal from the street. The AI sits above all of it simultaneously. What comes next is where this gets genuinely unsettling. The second revelation is that dark money networks have already adapted to the first generation of these AI tools, and the counteradaptation is more sophisticated than most people realize. This is the part that overturns the assumption that transparency tools automatically create transparency. Researchers at the Election Reformers Network published findings in early 2026 showing that between 2022 and 2025, the average lifespan of a dark money shell organization dropped from 6 years to under 18 months. The entities are being created, funded, passed through, and dissolved faster than annual tax filing cycles can capture them. Some networks have begun inserting deliberate noise, small, random grants to unrelated charities, specifically to confuse anomaly detection models trained on clean financial behavior. One documented network used 47 distinct organizational entities across a 3-year span, each one active for just long enough to process a single large transaction before being legally wound down. The 2024 cycle saw at least $180 million move through structures that had not existed 12 months prior. This is not amateur evasion. This is adversarial machine learning applied to money laundering. The people running these networks now employ their own data scientists to model what the transparency AI is looking for and engineer around it. You are watching an arms race in real time. The way the best AI tracking systems respond to this problem is through what researchers call temporal graph analysis, and it is worth understanding how it actually works because the logic is counterintuitive. A traditional database search asks, does entity A have a known connection to entity B? Temporal graph analysis asks a different question. Across all financial entities that have ever existed, which ones exhibit statistically improbable patterns of co-occurrence across time? The AI builds a rolling network graph where every nonprofit, every registered agent, every board member, every grant recipient is a node, and every documented financial relationship is an edge. Then it runs what mathematicians call a community detection algorithm, essentially asking the graph to identify clusters of nodes that are more connected to each other than chance would predict. It is like tracking a murmuration of starlings. You cannot predict where any single bird will go, but the flock's shape has a coherence that becomes visible from the right distance. When a new shell organization appears, even with no prior connections, the algorithm scores its probability of belonging to a known network based on who registered it, where it incorporated, what its officer names are, and what category of activity it claims, all within seconds of its first public filing. The counterintuitive element is that the AI often flags an organization as suspicious before it has done anything suspicious. The pattern precedes the behavior. The complications here are serious and deserve honest treatment. The same behavioral fingerprinting that catches bad actors will also flag legitimate nonprofits that happen to share infrastructure for cost reasons. Small progressive advocacy groups and conservative faith-based organizations frequently use shared registered agents and management companies because they cannot afford dedicated legal staff. A model trained on financial crime behavior patterns may systematically overflag under-resourced organizations while missing well-funded networks sophisticated enough to randomize their signatures. There is also a harder political problem. The decision about which AI findings get acted on by the IRS, the FEC, or the Justice Department is made by people appointed by administrations with their own funding relationships. The Washington Post reporting in early 2026 on the Justice Department under Todd Blanche documented significant staffing pressure and institutional reluctance to pursue politically connected targets. An AI can surface a network. It cannot compel prosecution. The gap between what the technology can see and what institutions are willing to act on may be the defining vulnerability of this entire project. Here is how this touches your life directly. If you work in journalism, nonprofit management, political consulting, or public policy research, AI-assisted financial network analysis is already changing your field. Investigative outlets including ProPublica and The Intercept have begun publishing AI-generated network maps alongside traditional reporting, which means readers and editors now expect visual evidence of financial relationships that previously required years of document review. Compliance departments at major foundations are running their own network screening tools before approving grants to avoid inadvertently funding organizations with opaque upstream funding. If you donate to any advocacy organization, there is an increasing likelihood that your contribution is being cross-referenced against network graphs you never consented to appear in. And if you vote, which is the most direct stake here, the policies on your ballot in 2028 are already being shaped by funding that these tools are only beginning to make visible. The trajectory of this technology over the next decade points somewhere genuinely significant. As AI models become faster at processing real-time financial registrations, and as international data sharing agreements between financial intelligence units expand, the window in which dark money networks can operate invisibly will shrink. The Financial Action Task Force is currently piloting a cross-border AI system that links corporate registry data from 43 countries. Within 5 years, researchers at Oxford's Internet Institute estimate that the average detectable latency, the time between a suspicious transaction and its algorithmic identification, will drop from 18 months to under 2 weeks. That does not end the arms race. It accelerates it, but it changes the fundamental calculus for anyone trying to move large